Hello friends, welcome to Nand Kishore classes. Today's lecture is going to be very interesting because today we are going to study how to count number of diagonals in a quick way depending upon if it is a quadrilateral, pentagon, hexagon, octagon, whatever it is. How many diagonals will be there? It is very difficult to count if you start doing manually. This is the first point we are going to cover. Secondly, we are going to cover concept of diagonal because it is always important to learn firstly what is a diagonal, how it is represented in a diagram. So let us start with, for example, I am taking a four-sided figure because diagonals start from quadrilateral, four-sided figure only. In a triangle, no diagonal is there. Now this is a four-sided figure which is known as quadrilateral. How diagonals are formed? See, just remember one rule. Take any point in the figure, any point. Go to next point, leave it, no need to do anything. Move to next point, join them. That means you need to join two non-consecutive points because points which are next to each other, they are going to form the side of your diagram, but other than that they will form diagonal. So following the same rule, if I go to this point, skipping the next one and going to the next, we are going to have two diagonal in a quadrilateral, which is very much countable. Two diagonals can be formed, but I want to show to clear the basic concept because this is very common, normally everybody uses. But when it comes to the next diagram, let's suppose I'm coming to pentagon. Okay, let's suppose this is five-sided figure. Let us draw pentagon first of all and let us start making its diagonals with the same rule as I told. For example, I am going to start from this point. This point to this point which is next, it is forming side of pentagon. Okay, but take join it with the next one, this one. This is one diagonal. Join it with this side, this corner, second diagonal. Two diagonals are formed. Now come to next point. Joining this and this will form side of the pentagon. Join this one here. This is again a diagonal. This one connected here, it's a diagonal. Moving to the next point, this one is forming side connected with the next one. See, next one is already connected, no need to do it again. Coming to the next point, see, already diagonals are formed. So this is what we have diagonals of a pentagon. Did you count it? Let us start counting it now. How many diagonals are there? This is number 1, number 2, number 3, number 4, number 5, number 6. 6 diagonals I can see very easily are being formed here. But manually even counting them becomes difficult and sometimes mistakes happens. Who knows, mistakes happen here also in this question as well. So there is a shortcut formula also where we can verify also, we can find also number of diagonals. And what is that formula? Number of diagonals formula is n times n minus 3 divided by 2. For example, this was a quadrilateral. Quadrilateral was having 4 sides. That means value of n is 4. If I substitute this value here, 4 times 4 minus 3 divided by 2, if you will solve it, you will get 2. Right, 2 diagonals are there. For pentagon, if n is 5, I'm using this formula 5 minus 3 upon 2. What will happen? Abhi dekho, abhi we are finding a mistake here. As I told, manual mistakes also happen. I am getting number of diagonals 5. There must be any diagonal which I have either counted twice. And yes, it is there. Which one is there? This 1 and 5 is written on the same diagonal. That is what I wanted to show. Manually, lot of mistakes happens. But this formula is important because of this reason. Because many people say, why you are making us learn the formula? Learning formula as a short trick is very helpful because otherwise things get messed. I also did the same. This 1 and 5 came at the same position. So number of diagonals are 5 here, and you have already seen 5 diagonals we had drawn. I'm going to move it to another shape, hexagon now. Because plotting the diagram is a different thing, counting is different thing. Usually questions comes in exam with count the number of diagonals, right? And I hope many of you must have noticed it when I wrote 1 and 5. Please write in the comment box those who had noticed it, right? Let's move ahead. Hexagon. Hexagon is having how many sides? 6 sides. Okay, 6 sides are there. By the time I am plotting the diagram, you can do the calculation using formula and can write in the comment box how many diagonals are going to come here. At least I will also get to know that you are understanding the concept or not. But let us plot the diagram. Why I am plotting it? Because this diagram looks very beautiful when diagonals are made. Start from here. This is one diagonal. This is two. This is three. So 3 diagonals I have found. Now I am writing it. Otherwise counting becomes very difficult when diagram becomes a mess. So 3 diagonals I have made as of now. I am starting from the next one. 1, 2, 3. 3 more. Starting from the next. 1, 2. Only 2 I have drawn now because third one is already there. So this point is already done. Moving to the next point, starting from here. This one is already connected. This one is already connected. So this one was left. So one more I have added. If I check from here, 1, 2, 3 is already drawn. 1, 2, 3 is already drawn. So 3 plus 3 is 6, 6 plus 2 8, 8 plus 1 9. Total I am getting as of now. Let us use the formula. Let us try out using formula. What was the formula? N times n minus 3 divided by 2. What is n? N is the number of sides, which is 6 for hexagon. If you cancel 6 with 2, we get 3. 3 multiplied 3, it is 9. See, formula is also giving 9. Manually, we have counted it is 9. But I had counted while plotting only. Once it is already done, then you keep on counting. Mistake is about to happen. That is why formula is important. So I tried my best to clarify the basic concept along with the formula. Wherever, whichever situation is, you can use both of them. Thank you so much for watching today's video.